Hello. In today's lecture, we will continue working on chapter 4, and in particular, I will be solving exercises using systems. Okay, so two body problems, that is what we discussed in yesterday's lecture. So if two bodies are connected by a string so that the bodies have a common acceleration, it's possible to use the system approach to calculate the acceleration. Newton's second law for the system approach is summation of F external equal M1 plus M2A, where F external are external forces along the line of motion. Okay, along the line of motion. Tension is considered an internal force. Okay, so this equation, I can only apply it to find the acceleration. But if I want to find the tension, then I have to use the normal summation of Fx equal Ma, summation of Fy equal to 0. So let's solve this problem. Two boxes of fruits on a frictionless surface are connected by a light string where M1 equal 10 kilogram, M2 equal 20 kilogram. A force F equal 20 Newton is applied on M2. The first part is draw a free body diagram for forces acting on each box. When we come to draw the free body diagram for two objects, we are free. It's either we take each particle alone, so we say this is one object, this is another object. The forces acting on the first one are weight and tension, okay? And the second one, there is weight, 2 and 2, tension. These are the same tension, so we don't say tension 1, tension 2. And then there is this applied force, and it's a frictionless, so there is no friction. So this is one way. Or another way, and it's also you're free to do it. So in this problem, actually, I did both ways, so as you use the way you like. So first, there is this surface, so I have to draw the surface. And then I have the two objects. So this is object 1, and this is object 2. I'll draw them a bit far away from each other. And then we are free to connect them with the rope. Okay, so we connect them with the rope. And now we apply the forces on them. So the first one, M1, there is W1. There is W1. There is N1. Okay. And since there is a rope, so there is tension 1, but we would call it tension because this is the same rope. The second object, there is W2, because it's a different mass, so it's W2. And then N2. And then there is the tension. And then there is this applied force. Okay, so let's put the name. So here is N1, W1, N2, W2, tension, tension, big F. And all of them are vectors, so we put the vector sign. Now, this is the first step. We draw the free body diagram. The second step before we continue is we choose x-axis and y-axis. Since the objects are moving to the right, then the x-axis is to the right. Okay, and for both of them. And then for each one of them, the y-axis is upward, upward. Okay, and this is here. X-axis, this is here, y-axis, this is here, y-axis. Okay, so we draw the free body diagram. It shows the x-axis, y-axis. Now we can do one more thing, that is for each force find its x component or y component. Actually, we can do this, yeah. So N1, it doesn't have an x component, so it's only has y component. W1, same, it's only on the y-axis. So 0 minus W1 because it's in the opposite direction. Tension for both of them, no, not for both of them. Tension for this one is positive, it's in the positive direction. But for the second one, it's in the negative direction. Minus T0. And then finally, this F, it's in the positive x-axis, going with the positive x-axis. So it's also plus F. Okay, so now we finished. Now determine the acceleration of each object. So we will use the system approach. There is two ways to solve this problem as discussed in yesterday's lecture. One way is dealing with each object separately. Okay, so we take, I'll do the technique, but you can find the solution in the coming slide. So this is the solution if we deal with them separately. Okay, so the way to do it separately is we say on object one, summation of, the question is to find the acceleration. So we have to use the first rule, summation of fx equal to ma. Summation of fx, n1, 0, w1x, 0. So I only have t. This is equal to m1, which is given 10 times acceleration. Okay, so this is on object 1. Then I do the same on object 2. On object 2, I use summation of fx equal to m2a this time. What remains here is minus t, because tension is in the negative x-axis, in the opposite direction to x-axis. N2 and W2 are 0. They don't have y-x components. And then F is plus F equal to M2, which is a 20A. Okay, so instead of T, I will put this value here, T equal 10A. So this will be minus 10A plus F, which is given 50, equal to 20 times A. If I take the A's to one side, it will be 30A equal to 50, implies A is equal 1.67 meter per second squared. Okay, so this is one way to do it. Just I want to put here, this is 0 and 2, and this is 0 minus n. Okay, so I determined the acceleration of each object using two equations to unknowns. Then determine the tension in the string. To determine the tension, I can use this formula now. Tension is equal 10 times A, so it's equal 10 times 1.67. So tension is equal to 16.7 meter, Newton. Okay, so we solved the problem. This is on a frictionless surface using two equations and two unknowns. Then it tells me, let's do exactly, okay, let's solve the whole problem first using two equations, two unknowns, and then we will do it using the system approach. So repeat the problem in case there is a friction now, and the kinetic friction is mu k equal to 0.1. So I'm going to repeat the same problem. So let's repeat it in red. Now there is a friction, so I have to go back to my free body diagram and add friction. So now the first object there is friction, and also the second object there is friction. Okay, so I draw it in red in order to see it. So here now there is friction, and this is minus F0 because it's on the x-axis, but in the opposite direction. And this F over here, similarly, this is minus F0. And it has a vector on top of it. Okay. So let's solve it here. So similarly, I will do on object. Let's do it in red just to make it. So this is part D now. So on object one, what do I have? I have minus F on the x-axis because we will also be doing summation of Fx is equal to 0. So what do I have? I have minus F plus T, right, is equal to, not 0 here, it's equal to M1A. So this is equal M1 times acceleration. F is mu times N plus T is equal to M1, which is 10 times acceleration. Okay, mu I know it's 0.1, it's given. But what I don't know is this N. Okay, but I can get it. In order to get N, we do summation of Fy is equal to 0. So I have N1. The friction doesn't have a y component. The tension doesn't have a y component. I only have N1 and W1 have y components. N1, the y component is a plus N1. W1 is minus W1. This is equal to 0. So N1 is equal to W1, which is M1G, which is equal to 10 times 10, which is equal to 100. So I come back to this equation. This will now give me, it becomes minus 0.1 times 100 plus tension equal 10 times acceleration, or tension is equal 10A plus 10. Okay. This is on object 1. Now I have to do the same thing, but on object 2. So I come here on object. On object 2, summation of Fx equal M2A. Similarly, what forces do I have here on the x-axis? I have minus T, I have minus F, and I have a plus F. These are the forces I have. This is equal to M2, which is 20 times the acceleration. This is minus T, so this is minus 10A minus 10. I plug this thing, I plug this T over here. Okay, let's continue. Minus F, which is minus mu, which is 0.1, mu 0.1 times N2 plus F, I have F, it's 50, is equal to 20 times acceleration. To find N, I will do exactly what I did over here. So I will do exactly what I did over here with the first object, and I will get, so using summation of Fy equal to 0, I will get N equal to W, and this will be 20 times 10, so 200 Newton. This is N2, by the way. Okay, so this is N1 here. N1. Okay, so now I plug it in this equation. I plug it in this equation. right? So I will have, I take minus 10A to the other side, so they will be 30A, okay, minus 10 minus 0.1 times 200, so minus 20, plus 50 is equal to 0, 30A equal 50 plus I take all the A's, let's do this. So well, let's take all the A to one side. Okay, so I took this minus 10A to the other side. So now I have 30A equal to minus 10 minus 20 plus 50. So 30A equal to 20 implies A is equal to 20 over 30. This is 0.67 meter per second square. And to find the tension, I will apply this formula. Minus T minus F plus F equal 20A. So I will apply this formula over here. It's not so clear, I'm sorry, but this is the one I will use. Let's do it over here. So I will use minus T minus F plus F equal 20 times A. So just a second. No, I will not use this one. I will use this one here. This one. T is equal 10A plus 10. So T is equal 10 times A, which is 0.67 plus 10. So I get T equal 16.7. Okay, so I solved the problem using the two equations in two unknowns method. Now I'm gonna do the same thing. So clear all drawings. So here you will find the solution using the two equations to unknowns. Now I'm gonna solve the same problem, but using the summation of F external. Let me put it here. Summation of F external is equal M1 plus M2 times acceleration. Okay, together we will do without friction, and then you can do the with friction on your own. You can find the solution in the lecture. So let's do this. So again, I need to draw the free body diagram. It's the same free body diagram. So I have this surface, I have this object, I have this object. They are connected by a string. Okay, so the forces are, I have W1, I have W1, I have N1, I have tension, I have W2, I have N2, I have tension, and I have friction. And here I will solve it without friction. Okay, then we have to choose the x-axis in order to know which forces are along the motion. So it's moving in this way. So what are the external forces? What are the external forces? This is here, W1. This is here. Oh, sorry, this is not W1. This is N1. This is W1. This is M2. This is W2. This is tension. This is tension. And this is the friction, the applied force. They are all vectors. So I put the sign for the vector Okay, now what are the external forces? So I want to apply, because these are two objects attached by a spring, so by a string. So I want to use summation of F external equal to M1 plus M2 times the acceleration. Okay, what are the external forces along the line of motion? So what are the forces along the x-axis? Here I have x, the motion is on the green. Here I don't need the y, because I only need the forces along motion. Okay, so the green is along motion, right? So what are the forces along motion? I have the tension, but tension is not counted. It is an internal force. And I have the F. So I only have this F is equal to M1 plus M2 is equal to MA is equal to, sorry, F equal M1 plus M2A. This F is 50 is equal to 10 plus 20 A implies A equal 50 over 30, and this is equal, just like in part 1, 1.67 meter per second squared. So notice how easier it is to solve the problem using the system approach. Then to find the tension, I cannot use this anymore. I just get the A. But in order to get the tension, I have to use either summation of Fx or summation of Fy, depending where is the tension. And I have to use it either on object 1 or on object 2. I don't have to put it on two objects. So let's do it on object 1. So summation of forces, let's call it F1x, or summation of x equal M1 acceleration. So what are the forces along the x-axis for object 1? There is only the tension, and it's in the positive, so it's T equal to, that's it, N1, the x component is 0, W1, the x component is 0. So I only have the T. This is equal M1, which is 10 times A, so this is equal 10 times 1.67, and this is equal to 16.7 meter per second square. Sorry, this is meter. Okay. So we solved the problem using the system approach. Down here, you can find the solution using two equations to unknown. Here in the case of friction, this is the solution using two equations into unknowns again. And then using the system approach. So this is for no friction, without friction, and this is with friction. Okay. So this is it for today's lecture. Have a good weekend, and next week we resume.